Yes, so you would have started with our, we have started our first unit DSA with uh, general introduction of what is data structure and what is abstract data type, and with we also saw how your subject is going to be. So generally we have a DSA is subdivided into two types, that is linear data structure. So data structure is divided into two types: linear data structure and non-linear data structure. So in linear data structure we have many things like array linked list. Okay, so array linked list and stack and queue in linear data structure. Okay, and in non-linear data structure, we'll be seeing about trees and graph. Okay, so second unit we learned what is an array and how to implement stack and queue using array. Okay, so array is a linear data structure, and through array we can implement stack and queue. Okay, so stack works in the principle of last in first out, and first in last out, and similarly queue will be working based on the principle of last in last out, or first in first out. Okay, so we have seen applications of stack by using conversion of postfix notation. Then we saw the recursive function, how it happens by using stack. Then we saw what are the types of stack, that is types of queue, that is linear queue, circular queue, and finally we saw what is DQ. Okay, so this is how your second unit is about. Okay, we have seen these things in our second unit along with some algorithms. Now we are coming back to first unit, that is data structure introduction part. Okay, so we have seen what is data structure is about. So data structure is about arranging of data or organizing of data in your computer memory. Organizing of data, okay, in computer memory. So you are storing a file, so that is some kind of data structure is happening behind. Okay, so whatever you're storing is organized in a proper way, it is sorted, it is organized in a sorted form, so which makes us to easily retrieve the data from the system or your phone, anywhere wherever you have stored your data. Okay, so that is how the data structure is working. So that behind the function behind is data structuring. Okay, so we have so this we are going to this in first unit we have seen what is data structure. Now we are going to see what is algorithm and how the algorithms are analyzed. Okay, so by the word algorithm you can say, okay, you would have learned this term in your programming language, that is your algorithm is a step by step instruction through which you can make the program. Okay, so it's a step by step instruction. Okay, so step by step instruction, it is not a program, it is actually not an implementation, but it is a previous or prior to an implementation. Okay, so it will just have a logical part of what your or how your program is going to be. So that is what your algorithm is. Okay, so the algorithm is a step by step instruction of how your program you're going to be creating or you're going to develop. Okay, so that we know. Okay, so you have created an algorithm, so for whatever a problem may be. For example, if I'm giving you a problem for to sort a number, so I'm giving a set of numbers like 5, 9, 2 and 1. Okay, so I'm giving so to all the people in the class I'm giving you numbers. Okay, and I'm asking you to create an algorithm to sort. Okay, in ascending order. Okay, so now I'm giving you a program, not a algorithm. I'm going to give a program to create a sorting algorithm, sorting, okay, sorting in an ascending order for the given numbers. Okay, so what you will do, each one will be creating your own set of algorithms. Okay, so in much simpler way, I'm asking you to find an answer 5 by whatever the operations may be. Okay, whatever the operations may be, whatever numbers you're taking, but you can have any kind of things. Okay, to have an answer 5. So my aim is to get an answer 5. Okay, but whatever you can have any number of steps, whatever operations you get, or any number of operations you can use, or any kind of symbols or any kind of numbers you can use. Okay, so whatever, so each one will be getting 5 in 5 different ways, not only in one way. Not all will give you answer, give me answer like 2 plus 3 will give you 5. No one will give me this kind of answer. Some will be giving 8 minus 3 will give 5, or 5 divided by 1 will give you 5. So like give me 5. So any many will be creating many different number kind of uh, steps to give me an answer 5. So this is what an algorithm is. So algorithm is any kind of steps to give a right answer. Okay, so you have to to solve a problem. So here the problem is getting answer 5. Okay, so I gave you a problem statement of getting an answer 5. So whatever any you have many different kind of solution to get an answer 5, right? So
Excuse me, ma'am.
yes.
Ma'am, some people are waiting to join the meeting, ma'am. Could you allow them, ma'am?
No, I can't because I will not allow them because it's already 2:10. Okay, so fine. So okay, so stop disturbing my class in between. Okay, so yes, so we are an algorithmic part. So since we are so to solve a particular problem, we have n number of solutions, and these n number of solutions are typically called as algorithms. Okay, so before getting into the programming part, okay, we are in the algorithmic part. Okay, so algorithmic part to solve this particular problem. Okay, so this algorithm will not have a single algorithm. We have n number of algorithms to solve this problem. Okay, so there will be a problem. Okay, so this problem can be solved by different types of algorithms, and we have to choose a best algorithm from that, and from that best we are creating a program. So this is how the flow will be. Okay, so the problem for a particular problem, there you will have many solutions. From that you have to pick a best solution, and from that solution you are going to create a program. Okay, that is what you are going to do. Okay, so for solving a problem, okay, so you will have so for solving a problem, sorry. So for solving a problem, I told you have a number of algorithms. So how you are finding a best or suitable algorithm from the available algorithm? Okay, so person what will be giving me an algorithm, another person will be giving some other algorithm. So if there are 80 algorithms, how I'll choose the best algorithm from the available algorithm? So in order to choose a best algorithm from the available algorithm, you have to go for efficiency of an algorithm. So through the efficiency test, we can choose the best algorithm from the available algorithm. So efficiency, how this efficiency is calculated? Through time and space. So you're taking time and space as a criteria to choose an algorithm in a or to choose an algorithm. 1 minute. Fine. So you have n number of solution. Okay. So through efficiency, time and space efficiency, we can choose the best algorithm out of available solutions. So available algorithm. Okay. To solve a problem, you have an algorithm. You have not only one algorithm, you have many algorithms. But from the many algorithms, how you will choose a pick a right one? Through the efficiency test. This efficiency is managed by, or if this efficiency is calculated through time and space complexity. Okay, so this is what we are going to see today's class. Okay, so the algorithmic analysis is through the efficiency to time and space complexity. We could say this is the best algorithm, and we can leave the rest of other algorithms. Okay, so time is the time taken to complete the working of an algorithm. Similarly, the space is the space occupied when the algorithm is created. Oh, we can create we can create this algorithm. Okay, so as I told you, this algorithm, this efficiency, you could have thought that this efficiency can be calculated when the or calculated during your program part. but that is not possible, because some program, for each program we cannot give values and we cannot get an answer. Okay, so it will take long time to find the time complexity. But if you're using this efficiency during your uh, algorithmic way, the algorithm itself, then you can easily find the right answer or find the right time complexity for an algorithm. Okay, so that is what prior and posterior testing. Okay, so you have to do the testing part during your implementation, at the implementation, whether your program is not working properly or not. But you have to do the analysis part in before the program. Okay, so your algorithm, so implement, so program in the program you have to do only the testing. Okay, but in the algorithm you can go for efficiency test. Okay, because if you are doing this efficiency, so this efficiency test can be calculated by using time and space complexity. Okay, but if you are doing this efficiency test on program, you cannot get, you are not having n number of programs, you have only one program, but you have n number of algorithms. From that you can choose a best algorithm. One thing. Another thing, if you are checking for time and space complexity of a program, that will take a lot of time to find the complexities, because every program has gives you an output. And if you are trying with some other input, it will give you an output. So likewise, we cannot exactly find the efficiency, time complexity or space complexity through program, but in the algorithmic part itself we can check, we can find the time and space complexity. Okay, from so the problem, if you got a problem in your hand, you can solve this problem by using algorithm. So you will have many algorithms, but to choose the best algorithm from the available algorithm, you can do that by using time and space complexity. Okay, so this is what your analysis part. Okay, so there are many things. Okay, so post priori analysis means you are going for uh, it's a theoretical analysis of an algorithm. Efficiency of an algorithm is measured by assuming that all the factors, for example process speed, and constant, and it doesn't have any effects on the implementation. So if you're doing priori analysis on algorithm, it will not affect the program that you're going to develop. Okay, so that is what you need priori analysis before implementing a program. Similarly, a posterior testing means you can do testing part. This part you'll be studying in your software engineering. Okay, so in posterior testing. Okay, so in posterior testing, you can have many testing methods to check whether your program is running properly or not. Similarly, in your lab work, you're testing, you're implementing and testing whether your program is giving you a right output or not. Okay, that is what your posterior testing is. But prior analysis happens only on the will be done only on the algorithms. Okay, so okay, so that is what the difference. So here the difference between prior analysis, it's done on algorithm, it done on program. It is independent of language. So algorithm can be developed in any language, C, C++, Python, anything. You can develop algorithm on any language, but posterior testing can be it depends upon language. Okay, each testing differs for each language. Okay, so each programming language. This language represents programming language. So each testing happens on different programming language, and this is hardware independent. Okay, so it doesn't depend on the hardware that is implemented in your system, but this program language depend on the hardware that you are using in your system. Then here the efficiency is calculated by using time and space, that is f of n and s of n. Here it is just a runtime. Okay, this runtime denotes that runtime of your program. This time and space denotes the runtime of your algorithm. Okay, so that is the major difference between priori analysis and posterior analysis or posterior testing. And we are going to see or do only priori analysis, because we are using only algorithms to learn how actually the program is working. Okay, so we'll see some examples how priori analysis is made on an algorithm, and based on the analysis how the time and space complexity is calculated. Okay, so why do we need algorithm analysis? Why do we need? So a problem can be solved in more than one ways. Okay, so many solution algorithms can be derived for a given problem. So we analyze available algorithm to implement best suitable algorithm. So you have many ways to solve a problem, and we have made through the you have many options to solve a problem, but we have to choose only one option from the available option. To get the best option, we are going for the time and space complexity analysis to choose the best. Okay, so you have 5 algorithm in your hand. You are applying time and space complexity on each algorithm to get the best algorithm. Okay, so how we are choosing, how we are finding it. For example, here I have given you the swapping sum. Okay, you would have known this swapping, how this swapping happens. Initially, you'll have a variable. For example, there are two variables, a and b, and I want to so a holding value 5 and b holding value 6. I want to swap these two values. Then I'll create a temporary variable, and I'll first put my value of a here, and after that I'll put value of b. So now the value of a is empty, so this variable is empty. So now I'll put the value of b into a. Then again I'll put value of b into temporary variable into b. So likewise you can swap. Okay, so just you're swapping. Okay, so so how the time and space is calculated in swapping. Okay, so here this is the algorithmic part. Okay, so this is your algorithm. Okay, so here we are using this by using recursive so function. Okay, so the function is created, so now it is begun. Okay, so now temporary variable is created and the value of a is assigned to temporary variable. Then your variable a is, okay, variable a is so value of a b is made into A. Then again, the temporary variable value is put inside B. So this is what happening. Okay. So now the time complexity. So how the time complexity is calculated based on how much time it is taking to declare and the doing some other process. Okay. Doing the process. Okay, so fine. So here, when you are assigning a value temp to A or A to temp, what how many time it's taking? It's taking only one amount of time. Similarly, when you are assigning value A to B, so only one time it's doing. It's not in a loop or it is not doing again and again. It is not implement or assigning the value. It is just happening one time. So that is one amount of time. Similarly, when you're assigning value of A to B or B to A, it is taking one amount of time. Similarly, B to temp, it takes one amount of time. So totally it takes about 3 times. Okay. So to denote time complexity, constant time value is represented by big O of 1. Okay. So totally it takes 3 amount of time, but it is in algorithm. So we should always use constant terms 1, and some other values you should be denoting as n and n square likewise. Okay, so it since it's a constant, so totally you can denote it as big O of 1. Okay, big O of 1. Okay, so it takes 3 constant time to assign a value to do a swapping. So instead of putting 3 there, it's since it's a constant, it takes overall it takes one amount of time to swapping. So we are denoting in at as big O of 1. Okay, if it is happening in a loop, okay, suppose if there is a loop and it is keep on doing, so it will take that n times to complete, because if as long as the loop is working, that many times it will take to give a value or to get a value or get an output. So if it is for looping, that takes that amount of time, loop amount of time to complete. So usually looping will have n, big O of n. If there is a constant time, then it will be denoted by 1. Okay, if you are dividing a problem, for example in binary search, you'll be doing searching by dividing a problem. So that time, the time complexity will be log n times. It is dividable, so it will be log n times. Okay, so likewise you can denote in some different ways. Here the swapping happens for one constant time for each assignment. Okay, while assigning here, it takes one constant time, this happens one constant time, and this happened for one constant time. So because of this takes overall it takes 3 constant time to do entire swapping. So what I'm telling is, what we can say is, overall it takes one constant time to do an option, to do a this operation. Okay, so that is what. So f of n is used to denote the time complexity. Similar way, S of n to denote the space complexity. So S of n is space. So A, so here there are only two variables A and B. Okay, so A holds a value and B holds a value. Temporary is a variable, just it's created to hold a value for temporary amount of time. So only that is not assigned with any value. So for A, it occupies one space, and for B, it occupies one space. Temporary variable is holding the value for temporary amount of time. So it is not initialized with any new values. Okay, so A holds one value and B holds one value, and temporary amount of time value is also holding one value at certain time. Okay, so because of this, this holds three space values. Okay, so once the A is initialized, A occupies one value in one position in memory, B occupies one position, and temporary value or variable also occupy one position. So altogether, three position is occupied by these three variables, and in algorithmic way, we can say this since it is a constant without any polynomial values, so we can say we can represent as big O of 1. So the time complexity of this particular swapping will be swap is big O of 1 time, and space complexity of swap is big O of 1 time. Okay, so likewise we can denote. So we'll see one more example: addition of numbers in an array. Okay, so addition of numbers in an array, you know how the addition actually works. Okay, so if there is an array, okay, 5, 3, 1 and 2, we are going to add all the values in the array. 5 plus 3, that with that we have to add this value, and with that we have to add this value. So likewise, we have to add the values, okay, one by one. Okay, so to do that, we'll always use the for loop. Okay, so this is your algorithm. Okay, I hope you know how the actual working of a program. So this is an algorithm. Okay, so here sum of array with the values n. Okay, so here it is initialized. Okay, so here s is initialized to 0. Okay, so when s is written initial, so this is what you used for summing. Okay, this variable is used for summing. Okay, so s is equal to 0, it is initialized, it happens for one amount of time. So compiler, the computer will come here and will check and will assign a value or a position in a memory. So this takes one unit of time. Then here for loop. Okay, for loop I is equal to 0, I is less than n, I plus plus. So what is happening here? For I is equal to 0, the loop will be working. Okay, so what happens for I is equal to 0? S is equal to, S is initialized to 0, so S is equal to 0 plus what is ith position? So this was 0, 1, 2, 3. Okay, so first zeroth value will be added here. Okay, so that will be stored in S. Okay, now what happens once this is done? Now again the S will be, so I will be incremented. Okay, I is equal to 2 now. So S is equal to, already it is 5 plus next value is 3 is 8 now. So S holds the value 8 now. Again I is incremented. I is incremented. Now S is already 8. Okay, from the previous value it is 8. Now it is be adding with the second index, that is 1. Okay, so 8 plus 1 is 9. So S holds the value 9. Now I is incremented to 4, and S is equal to 9 plus 2, it is 11. Okay, now again I is incremented to 5. Okay, when I is incremented to 5, we'll check whether I is less than n. So here the value of n is equal to 4 because we have only 4 values in the array. Okay, so I is less than 4, 5 is less than 4, no. So it will exit outside the loop and it will return the value of S. The value of S will be 11. Okay, so this is how the sum of array happens. Okay, so here what happens is the for loop worked for 1, 2, 3, 4 times, and one time for the false condition. So for true condition it worked for 4 times, and for false condition one time. So it happens for how many true times? That is 4. So value of n is equal to 4. So it happened for n times. So 4 true times and 1 time. So instead of doing in this values, I can say it happened for n time with one false time. Okay, so n times for true condition and one time for false condition. To say that I have so the for loop worked for n true times and 1 false time. And similarly, here addition happened for 4 times, 1, 2, 3, and 4 times. So I can say this as n times. Okay. So the statement was declared. So when the S was initialized, it happened for 1 time. And here this loop worked for n plus 1 time, that is n true time and 1 false time. And here the sum operation happened for n time. So totally 1 plus n plus 1 plus n. Okay. Similarly, you can also take for I. So initialization I happened for 1 time. And when you are getting value of n, you are initializing n, you would have initialized n. So that happened for 1 time. So whatever time number of times may be, from this, you can say that initialization happened only for 1 time, but the loop happened for n plus 1 time. The addition operation happened for n time. As long as this loop is alive, this addition was happened. But the false condition, for the false statement, the loop didn't work. Okay, the sum didn't work. Okay, so as long as the loop is alive, this sum was happening. The loop exit, the sum was not calculated. So think in that way. Okay, so how many times it happened? For 2n times plus 3 times, 3 constant times. Okay, so I just did a normal polynomial normal calculation. So what you can see, so from here you have 2n plus 3 times. Okay, so altogether I can make this as big O of n times. Okay, so it has only one polynomial. Okay, polynomial of n. So okay, so I can say this as it happened for big O of n times. Similarly, for assigning the for the space complexity. Okay, so n initialization get taken 1 time, a s happen 1 time, because s is keep on doing, but it is holding only one value till the end. So it happened for 1 time, and I is initialized for 1 time, and array is of n times. Okay, so here array, the value given by the user, based on the value given by the user, only the array will be created. If the array was created for 4 values, then that will be 4 values will be there. And if the array is created for 3 values, 3 values, 3 number of values will be there. So likewise, your array is created. So array happens for n times. Okay, so because of that, your space complexity will be big O of n. Okay, so these can happen for 1 time. Okay, because this n will be holding only one value, s will be holding only one value, I will be holding only one value, but this array will be holding the values given by the user. That is, if the user gives 5 values, the array will be created for 5 variables. If the user gives 7 values, 7 as your input, then the value array will be created for 7 variables. So based on the input, that is based on the n, only the value of array changes. So okay, so because of that, it happen, array will be happen for n time and 3 for the other 3 variables initialization. So totally you have n plus 3. So totally we can make this as big O of n time. I hope you are getting what I'm teaching. Okay, we'll see with only this and we'll wind up the session. Okay, so here similarly, here addition of square matrix algorithm. So for addition of square matrix, I already told you for loop will work for n true condition and 1 false condition. So this for loop will work for n plus 1 time. Similarly, you can say this for loop also work for n plus 1 time, but this for loop is inside this for loop. So as long as this loop running, this will be executing. Once this loop exits, this will be stopping. So for that, it happens for n time. Okay, as long as this for loop running, this for loop also will be running. So for n times it will be running, and this for loop will be running for n plus 1 time. Okay, so here it is what is happening, you are just adding two values, that is n value of a and n value of b, you are just adding. So it will take n cross n time. So totally this happens for 2n square plus 2n plus 1 time. So the polynomial will be n square. Since the highest polynomial is n square, so you'll be taking big O of n square times. Okay. Similarly, here, since this is a matrix, it will always happen in n plus n cross n. Your matrix will be always denoted in m cross n, with another matrix will be m cross n. So obviously your space will be occupied for n square. And you have to remember, always the time complexity and the space complexity will not be same. Sometimes time complexity will be n square times, but the space will be occupying for n size. Okay, so do not confuse or do not take that time complexity and space will be same, and because of that you just blindly don't make whatever time complexity comes as space complexity. Sometimes it differs. Okay, so see here in this example, matrix multiplication, where your time complexity is n cube but your space complexity is n square, because matrix will have n cross n values. So based on the space occupied, it will be n square only. But here, since it's multiplication, there are three for loops. For loop for getting value of I, for loop for getting value of j, then you are multiplying. For that also you are doing using for loop for multiplying the two I cross j. So because of that, it happened. You got n cube for time complexity, but the space complexity is only n squared. So don't confuse and don't think that time complexity and space complexity will be equal. So other problems we'll see in tomorrow's class.